Hello student, good morning. I am Dr.AJAY Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numericals based on chemical equation. These numericals are very important for A.I.M.S, IITJEE and NEET exams. Now I will discuss from question number 278 up to 277 I have discussed. Now I am going to discuss questions from 278. Now I am reading the question. 3.92 gram of ferrous ammonium sulfate crystals are dissolved in 100 ml of water. 20 ml of this solution requires 18 ml of potassium permanganate during titration for complete oxidation. The weight of KMnO4 present in 1 liter of the solution of first option 34.76 gram, second option 12.38 gram, third option 1.238 gram, fourth option 3.476 gram. Again one more time I am reading the question. Actually you should keep pen and paper with you so that you can solve it quickly. Okay. Again I am repeating the question. 3.92 gram of ferrous ammonium sulfate crystals are dissolved in 100 ml of water. 20 ml of this solution requires 18 ml of potassium permanganate during titration of complete oxidation. The weight of KMnO4 present in 1 liter of the solution is first 34.76 gram, second 12.38 gram, third 1.238 gram, fourth option is 3.476 gram. Okay, this question is little longer and full of concept. You can solve it. Okay, just you think. After that I will give the hint. You have to calculate the weight of KMnO4 present in 1 liter of the solution. Okay, first option is 34.76 gram, second option is 12.38 gram, third option 1.238 gram, fourth option 3.476 gram. Just to think. Now I am giving you hint. Equivalent weight of ferrous ammonium sulfate, that is actually 392. You must remember some common salts that you should know the equivalent weight. Equivalent weight of ferrous ammonium sulfate is 392. Then a normality of salt solution. What will be the normality? According to the question, 3.92 gram of ferrous ammonium sulfate crystals are dissolved in 100 ml of water. Then what is its normality? First you calculate. Then normality is equal to what? Mass divided by molecular mass. This equivalent mass, normality. Mass divided by equivalent mass. Then 3.92 divided by 392. Then you know that this amount is present in 100 gram. This amount is present in 100 ml water. 100 ml water. Then 100 ml water has you can say how much these things normality. Then you calculate very easily that 3.92 divided by 392. Correct? This is present in 100 ml. Then how much will be present in 1000 ml? That is normality. Correct? 100 ml contains 3.92 divided by 392 gram of ferrous ammonium sulfate. Then for 1, then for 1000 ml. Because normality is considered in liter, per liter. Then 3.92 divided by 392. That is the number of equivalent. This number of equivalent is present in 100 ml. Means 100 ml contains 3.92 divided by 392. Okay, these things equivalent. Then for 1, then for 1000, then it will become 0.1 N. Or directly you should remember 3.92 divided by 392. Correct? That is a easy way calculation is that is 3.92 and down is 392. Then it will be 1 upon 100, but it is present in 100 ml. You have to calculate in 1000 ml. Then it will become 0.1 N. Okay. Now, according to the question, 20 ml of this solution requires 20 ml of this solution, what you have made, 0.1 N, ferrous ammonium sulfate. 20 ml of this solution requires 18 ml of potassium permanganate during titration for complete oxidation. The weight of KMnO4 present in 1 liter of the solution you have to calculate. Correct? Then now 20 ml of this solution required 18 ml of potassium permanganate. Correct? Then during titration, because both are neutralizing. Correct? Then you have to calculate weight of KMnO4. 18 ml was required for complete reaction during the titration. Now here 20 ml of 0.1 N salt solution means how much? Actually 20 ml of 0.1 N salt solution that requires 18 ml KMnO4 salt. Okay, both are equivalent. 20 ml of 0.1 N salt requires is equivalent to 18 ml of KMnO4. Okay. Then normality of KMnO4, what will you have to calculate? Normality of KMnO4 solution. Then both are 20 ml 0.1 N ferrous ammonium sulfate, that is equivalent to 18 ml of KMnO4 salt, because both are neutralizing to each other. Then normality of KMnO4 solution will be 20. You know that you have to now apply N1B1 is equal to N2B2 formula. Then here 20 into 0.1 M, 20 ml, that is the V1, and its normality is 0.1 N ferrous ammonium sulfate. You calculated 0.1. Then Now you have N1, V1 you have used. Now normality N2, V2, then V2 is 18 ml of KMnO4. Then V2 you have to N2 you have to calculate. Volume you have to calculate, correct? And volume is given 18 ml. Normality you have to calculate of KMnO4. Then easily you can calculate N2 is equal to 20 into 0.1 divided by 18, means N1 V1 divided by V2. V2 is volume of KMnO4. Then after solving you will get 1 upon 9n. 1 upon 9n. Then now you should also know that equivalent mass of KMnO4 is 31.6. Don't forget. Equivalent weight of KMnO4 is 31.6. Then the amount you want per liter. Amount per liter you want. Then what will be the value? 1 upon 9n. You put the value of n. N is 31.6. Here equivalent mass is 31.6. Then the strength of KMnO4 solution will be 1.9 into 31.6. After solving you will get 3.5 gram per liter approx. Correct? If you will multiply by n, then you will get amount. Always remember. Then here 1 upon 9 into n. In the place of n, you write 31.6. Then after solving you will get 3.5 gram per liter approx. You will get, because always equivalent weight means per liter. Then 31.6 you have multiplied, that is for 1 liter. Then you got answer, you got 3.5 gram per liter approx. Hence correct option is option D. Last option 3.476 is given. That is the correct answer. Actually this question was asked in Tamil Nadu CET exam. Now next question I am telling you, 279, question number 279. 30 gram of magnesium and 30 gram of oxygen are reacted. Then the residual mixture contains, first option, 60 gram of magnesium oxide only. Second option, 40 gram of magnesium oxide and 20 gram of oxygen. Third option, 45 gram of magnesium oxide and 15 gram of oxygen. And last option, 50 gram of magnesium oxide and 10 gram of oxygen. Again one more time question I am reading. 30 gram of magnesium and 30 gram of oxygen, both are 30 gram, are reacted. Then the residual mixture contains, first option, 60 gram of magnesium oxide only. Second option, 40 gram of magnesium oxide and 20 gram of oxygen. Third option, 45 gram of magnesium oxide and 15 gram of oxygen. And last option, fourth option, 50 gram of magnesium oxide and 10 gram of oxygen. Very good question. Just to think it, I can solve it. Okay, it is not very difficult, but you have to just think how will you solve. When you will think properly, only then you can solve it. Okay, this you can solve it within 1 minute. Just to think. Now I am giving you hint. First you have to write the reaction between magnesium and oxygen. Then you know magnesium plus oxygen, it will give you magnesium oxide. Correct? The balanced equation you have to write. Then 2 Mg plus O2, 2 MgO. Then Mg atomic mass, you know, that is the 24. The 2 Mg means total weight will be 48 gram. 2 into 24, 48 gram. And O2 means 32 gram. Means for complete reaction, 48 gram magnesium requires 32 gram oxygen. Then it will give 2 MgO. Then MgO means what? Mg 24. O means 16. Then 24 plus 16, 40. Then 2 MgO. Then 40 into 2, 80 gram. Means you will get, if reaction is complete, then you will get 80 gram magnesium oxide. Okay. Then now 30 gram magnesium will react completely with O2. Here, according to the question, 30 gram both they have given. 30 gram magnesium, 30 gram oxygen. Reaction is between these two. Both are 30 gram. Then only on that basis of reaction, what I discussed now, you can solve it. Then 48 gram reacts completely with 32 gram oxygen. You remember. Then for 1 gram, then for 30 gram magnesium you can calculate. Then for 30 gram how much oxygen is required. Then for 48 gram, 32 gram oxygen is required. Then for 1. And then for 30. Means 32 divided by 48 into 30. 32 divided by 48. Because 48 gram reacts with 32 gram. Then for 1, 32 divided by 48. Then for 30, just to multiply by 30, you will get 20 gram. Then now, how much oxygen will you left? You have taken 30 gram. Now 20 gram only reacted. Then 10 gram will be left. 10 gram oxygen will be left. Okay. And magnesium oxide, how much it formed? Then 48 gram on complete reaction, it is making 80 gram MgO, magnesium oxide. Then for 1, how much? 80 divided by 48. Then for 30, or 48 from 48 gram on complete reaction, you will get 80 gram magnesium oxide. Then for 1, 80 by 48. Then for 30 gram, how much? Multiply by 30. Then on solving, you will get 50 gram. 80 divided by 48 into 30. You will get 50 gram. Then 50 gram magnesium oxide you are getting, and 10 gram oxygen is left. Then correct answer will be 50 gram of magnesium oxide and 10 gram of oxygen. Hence correct option is last option, D. Correct? This question was asked in KCET, Karnataka CET. This question was asked. Okay. Means in mixture you will get 50 gram magnesium oxide and 10 gram oxygen because it was left. Now I am going to discuss questions based on equivalent weight. Questions based on equivalent weight, numericals. Okay, all are numericals only. And actually these numericals may be asked in all competitive examinations. These are little tough, not very tough. I will come to the very tough also, but it is more than you can say average. Tough, coming under the tough only, not too much, not very tough. Then now I am going to discuss question based on equivalent weight. Now question number 280. 280 I am going to discuss. 0.84 gram of a metal hydride contains 0.042 gram of hydrogen. Its equivalent weight is first option 80, second option 40, third option 60, fourth option 20. See, all theoretical concept already I have discussed in details. Only then I have started numericals, all numericals. First I have discussed all theory. Okay, all concept already I discussed. Okay, then you can remember concept and only then you can solve it. Now again I am reading the question. Question number 280. 0.84 gram of a metal hydride contains 0.042 gram of hydrogen. Its equivalent weight is first option 80, second option 40, third option 60, fourth option 20. I think this question you can solve it. Okay, just to think. First to think, if it will come in your mind that okay, this can be solved like that, then only you can solve it. Now you think it. Thinking will take hardly 30 seconds, less than 30 second time. Just to think. Now I am giving you hint. See, you have to calculate equivalent weight of the metal. Correct? You have to calculate equivalent weight of the metal. And metal hydride is given. Metal plus hydrogen is given. Its mass is 0.84 and it contains 0.042 gram of hydrogen. Then now easily you can calculate that weight of metal divided by weight of hydrogen into 1.008. Correct? That amount of metal which will react with 1.008 gram hydrogen, that amount is called equivalent weight. Very easily. The amount of the metal which will react with 1.008 gram hydrogen, that is the equivalent mass. That mass is called equivalent mass. Correct? For chlorine 35.5, you know. For hydrogen 1.008. You remember. Then here hydrogen is there. Then weight of metal is given 0.84. Weight of metal. In that hydrogen is given. How much? 0.042. Then 0.84 divided by 0.042 into 1.008. Because 0.042 hydrogen reacts with 0.84 gram metal, then for 1, then for 1.008. Then after solving you will get roughly 20. Then correct option is option D, 20. Option D is 20. Then roughly you will get 20. Answer will come roughly 20. Here in option it is given 20. That is correct. One more question I want to discuss today. 281. Question number 281. A metallic oxide contains 60% of the metal. The equivalent weight of the metal is first option 12, second option 24, third option 40, fourth option 48. Again one more time I am reading the question. A metallic oxide contains 60% of the metal. The equivalent weight of the metal is first option 12, second 24, third 40, fourth 48. Just to think, quickly you can solve it. This question you can solve in very less time. Okay, hardly 30 to 45 seconds. If concept is clear, it will take hardly 30 to 45 seconds minimum between that. Just to think. Now I am giving you hint. You know, just now I told you that how will calculate equivalent weight. Then here weight of metal divided by weight of oxygen. Then just like for hydrogen 1.008, okay, and for chlorine 35.5, and for oxygen 8, means amount of metal which will react with 8 gram of oxygen. That amount is called equivalent weight of the metal. Here 60% is metal. It means rest is oxygen. Then here equivalent weight easily you can calculate that weight of oxygen. Suppose it was 100, 60% means suppose it was 100 gram, 100. Then 60% is metal, means 60 gram is metal, 40 gram is oxygen. Then 40 gram oxygen reacts with 60 gram metal. Then for 1, then for 8 gram. 40 gram oxygen reacts with 60 gram metal. Then for 1 gram, then for 8 gram. Correct? 40 gram oxygen reacts with 60 gram metal. Then for 1, 60 by 40. Then for 8 gram into 8, you will get 12. Correct? Always remember, if it is hydrogen and you have to calculate equivalent weight, then you should consider for 1.008 how much metal reacted with 1.008 hydrogen. If it is a chlorine, then how much metal reacted with 35.5 gram chlorine. And if oxide is there, then how much 8 gram, how much metal reacted with 8 gram of oxygen. This you remember. And now in this case you got 12. 12 is the correct option. Means option 1 is correct. This question was asked in EAMCET exam. Okay. Today I am stopping only here. Next class again I will continue. Thank you.